Welcome back to my video. I am Anusha of CSC department working as assistant professor in Institute of Aeronautical Engineering. In my videos, I am discussing about programming with objects which is based on Java. In the previous session, we have discussed about multithreading, what is the importance of multithreading and how multithreading is working in Java. So what was the importance of multithreading? So if we have any concurrent work to be done, this can be given to small pieces, this can be divided into small pieces and they can be given to small threads so that all these work can be completed parallelly. This will improve the speed of computation. So in Java, whenever a program starts, whenever we start execution of a main method, one thread will be created, which is the main. Now, if we want to create child threads, then we have two ways to implement. So we can create thread in Java by either using the Runnable interface or by extending the thread class. So these are the two ways by which we can create or spawn a thread in Java, by using a Runnable interface or by using a thread class, by extending the thread class. So if we are if we are implementing using Runnable or if we are using a thread class, we always have to implement the run method. So whatever logic we have to implement for a thread to work on, that logic we will implement inside the run method. So we have to create a class with either by implementing the Runnable interface or by extending the thread class. So we create a class using one of this method, and inside that class we will implement the run method. So if we are implementing it using the Runnable interface, then we have to create an object of that thread class of this form. We have to create the object of thread form. We have to create the object of the thread class by creating a Runnable type object, and we have to specify the thread name. So this is the if we want to create a thread using Runnable interface, then we have to instantiate an object, or we have to create a thread by using this structure. Okay, so and once we create the thread, then you have to call the start method on that thread, so that it will execute the run method and it will start working. So inside the run method, we will implement our logic. We can call other methods inside the run method, and also we can declare variables or anything. All the logic we will be implementing inside this run method. And also this run method is the entry point of concurrent threads. Like if you for another, so it established the entry point for another concurrent thread of execution within our program. Now let's look into a small example for implementing the Runnable method. To create a thread using a Runnable interface. So here we are creating a class named as Multithreading Demo 1, which will implement the Runnable interface. That means this is the thread which will be implementing our logic. So this will be the one which will be creating the child thread. Okay, so inside that we have to, as I've told you, we have to implement the run method. So we have to implement the run method. Now since there are chances that it may throw an exception, we are putting that inside the try catch block. So we are creating an instance of the thread. Now we are just checking what is the thread, what is the thread that is being running. We just have to see the description of that thread which is running. So we are creating an instance of that thread, and on that thread we are calling the getName method and getID method. So getName method will return the name of that thread, and getID will return the ID of that identifier of that thread. So inside this run method, we are implementing this part. So we are creating we are creating a reference to that thread, and we are retrieving the name and ID of that particular thread. So now in case it throws an exception, we are handling it inside the catch block. If that exception is thrown, then we are handling it inside the catch block. Now, next we have the class. We are creating the class for testing, which is a thread runnable, which implements the main method also. So we are simply displaying these two statements, implement runnable and inside main, so that we can understand the flow of the program. Now, right now it is inside main. So once it enters the main, it comes inside the main. And here at this point, again we are creating a reference to the currently running thread. So at this point, it is the main. Since the main has started executing, it will obtain the main thread's instance. So at this point, when we create a thread object, when we try to reference a thread object using current thread method, it will point you to the currently executing thread, which is our main thread. So we are printing these statements. We are retrieving the name of that thread. So we will get the main thread's name, its ID, and its ID. So the thread names. So it is displaying the currently executing thread name and the ID. And so here at this point, we have only main thread only is being executed. Only the main thread is executing. Now, to spawn a thread or to create a child thread, we have to create the object of the class which we have implemented before, right? So we have created a class which is implementing the runnable interface to create a thread. So now we have to create an object of this thread. So we are creating the object of this of that particular thread, and so this is if we are going for runnable interfaces, then we have to use this type. The thread constructor will be of this type. So you are creating runnable thread in the thread object. The thread object should be of runnable type, and we are providing some name for it. So here we are creating an object of the thread with the runnable type. So our class name was Multithreading Demo 1. So that same name we have to use it here at this point, and we are giving it a name as child. Now once this thread is object is created, we have to call the start method on that object so that it will start executing. So until this point, we have only the main thread executing, and when we call the ob.start method, it will create the child thread. So let's see how the output comes. So initially the program will start from the main method. So we will get this statement, implements runnable, in the output. Then it is displaying the inside main statement. Now at this point we are getting all the details of the main thread. So that is why we get thread. Then t.getName will return the name of that method, which is main. Then with ID, t.getID means the identifier of the main thread at this point is 1, and this running statement. So this whole statement we got it from this line, right? So we created an instance of the currently executing thread, which is the main thread, and we displayed that. Now we are creating the object of the child thread. So when we create the child thread, we created the child thread, and when you have to call the start method. So only when you call the start method will the child thread start executing. So when you call the start method, it will go into the method run of the child thread. So here it is displaying inside run, because of which we got this statement inside it. And then inside run again, we are displaying the thread name and the ID of that thread which is executing. So that was the child name. The thread name was, while creating the thread, we have applied the child name as child. So we get the statement thread child with ID 14, because that may be the 14th 14th thread which is being executed. So you get with ID 14 is running. So this is how we implement it using the Runnable interface. Next, another method by which to create a thread is by extending the thread, extending the thread class. So when you are extending the thread class, you have to again create a class which will create a new class which will extend the thread, and then you have to implement the whatever logic we need to. So here we have in this case also we must override the run method which is available inside the thread class. So again this the run method is the entry point for execution of any new child thread being created. So once we create a class with the thread by extending the thread class, then we have to implement the run method same as before, and then we will create an object of it of that, and then call start over it to begin with the execution. So now we can make use of the super method inside the new thread to invoke the thread constructor. To invoke the thread constructor, we may either invoke the super method or we can simply create an object of it and continue our work. So inside the thread class, there are several methods which is being defined. One is the getName method, which is used to obtain the name of that particular thread which is executing. The getPriority method will return the thread's priority. Priority means it is the some priority will be given to each thread. As we have seen before, the priority of the main thread is always 5. Then to check whether the thread is still running or not, we use the isAlive method. Then if we want to if we call this join method over a thread, then the other threads will wait for the current thread to terminate. So when we call join method, it will wait for the thread to terminate. The run is the entry point of any thread. Then if you want to suspend a thread for some period of time, then we call the sleep method. And if we want to, when we want to start a thread, then you call the start method, which will invoke its run method enter. Okay, so these are some of the methods which is available inside the thread class. So now let's look into an example which is implementing the thread class, which is creating a thread using the by extending the thread. Okay, so here we are creating a class named as Multithreading demo, which is extending the thread. Again, as I've told you, we have to override the run method inside that. So we are giving the same implementation as we have seen before. So here again we are creating an instance of that currently executing thread and displaying the name and ID. It's the same logic which I have implemented before is being used here. So we are displaying the name and ID of that particular thread which is being executed, and if it is throwing any exception, that will be handled inside the exception handler. So we are implementing the try catch block so that if any exception is thrown at by any of these lines, it can be caught and handled by the catch block. Next, we have now we have to create the testing thread. For that we have the main method is that we are creating an instance of the thread class again, so that it will point to the main thread, which is, so when we retrieve the name and ID, it will return the name and ID of the main thread which is executing at this point. Until this point, it is only the main thread which is being executed. Now here we are creating an object of the thread class of which we have previously defined. So we are creating the object and we are calling start. So when you call start, it will the child thread will start executing. So when it goes to the child thread, the statements which is implemented, the run method, the implementation of the run method will be executed. So here now let's look into the output. So first the execution starts from main. So at this point, from this point onwards, the main thread is executing. So we get the output extends thread. Then you are retrieving the we are retrieving the current thread instance, which is current thread instance, and uh, then we are retrieving the name and the ID. We are retrieving the name and ID. So wherein you get the main thread, the name of the main thread was main, and the ID of the main thread was 1. So we get the name and ID of the main thread. Now we created the child class. Once we created the child thread, and called start, it will start executing the run part of it. So inside run, we had retrieved the instance of the child class. So here it is a child class which is being child thread which is executing. And when you retrieve the name and ID, you get, we didn't since we didn't assign any name for that thread while creating the thread, by default the compiler itself will assign some name, so which is thread 0, its ID is 14, and the statements which were shown inside. So thread get name means it will, since we didn't apply any name as such, it will take its own name. The compiler will provide its own name, and that name was thread 0 and its ID was 14. So the statement will be obtained inside the output. Next we have now why Java was given two ways of implementing thread. We had the by implementing the runnable interface, and we can create thread by extending the thread class, right? So these were the two methods by which we can create any thread in Java. So which one we should follow? So basically we can say that it is better to use the runnable interface because Java does not allow multiple inheritance, isn't it? So if we have any thread class which is created by extending the thread class, okay, we are creating a thread by extending the thread class, then if this class want to inherit some property of some other class, this feature will not be allowed, because this will lead to, this is already a class, the thread is already a class, and now again we want to inherit some other class. This is, let's say class A. So this thing is not allowed in Java because this is called as multiple inheritance. So if we don't need any other feature to be inherited from some other class into our created thread class, then we can go for inheriting the thread class. Or else it will be better to always go with the runnable, by implementing the runnable interface, so that you can achieve the multiple inheritance feature also along with it. We have this. We have our child thread class, and this is the runnable interface. So if this child thread class wants to implement some other, wants to inherit another class, this is allowed because we have made use of the runnable interface. So when we are implementing interfaces, it doesn't stop you from making use of any other thread. Any other class. We can this thread class can also inherit from. It can also extend some other class also, say class A. So this feature is allowed only by using if we are creating thread by using runnable interface. It cannot be achieved by extending the thread class. So people may prefer making it to implement it using the runnable interface. Next, let's see how we can create multiple threads. So for creating multiple threads, as in the previous example, we have seen only two threads executing. One is the main thread and another is the child thread. Now, if we want to have more than one child thread to be executed, then what can we do? How it allows. So by creating multiple objects of the thread, we can create multiple threads. You can create multiple child threads. And if we have any work to be done, these work can be assigned to each of these thread. So in our case, we are simply seeing how we are executing how we are creating a new thread and assigning it some work. So here, in our case, we are creating a thread class by implementing the runnable interface. Then we are taking the we are taking the instance of this thread. Then inside the try block, we are making use of the for loop to get the name of that currently executing thread. And now we are calling the sleep on this thread. Okay. Now, so if any exception has been thrown here, we will catch this interrupt. That interrupt will be caught by the catch block and handled. So this interrupted exception will be thrown when we interrupt the thread which is being sleeping. So if we interrupt that sleeping thread, then only then this exception will be thrown. Interrupted exception may be thrown. Now inside the main method, we are creating 3 objects of that particular class, which is implementing the runnable interface. So which is basically implementing a thread. So we are creating 3 objects of it, and we are creating with giving 3 name. We are giving the name C1, C2, and C3. Then we are calling the start method. So once these start methods are invoked, then it will be once we call this start method, the child thread will be created. Now let's see how this will happen. So initially we call the start method on the object 1. So once you call the start method, the first thread will be created. So the first thread will be created, and we will be displaying the name of it, right? After displaying the name, it is going to sleep. So once this statement is executed, it is going to sleep. So what will happen? Once this is sleeping, by the time we can have this, the second second thread is started. So again, once this thread is started, it will again go into this run method, and it will take its own name. So what will we get? In the first case, it will be for C1, and some C1 will be displayed, and I value was 5. Okay. Then in the second case, you are calling start method, right? So on the second object, second thread, we are calling the start method. So what will happen? That will also come here, right? So that will also come here. It will come into its run method, and it will start executing the for loop. So you get C2, get name C2, 5. Now third object is being created. So again, what will happen? It will start executing. So it will start executing, and you will get C3, 5, right? So now the point to be noted here is that these threads are being created by the operating system when we invoke it. But at which point which thread will be executed, that cannot be determined by us. So it may not be always C1, C2, C3. The order may change. So if you check the output, the order of execution of the threads will keep changing. So that completely depends on the operating system which we are using. So in our case, let's see, the output is, first we have the C1 thread created, then we have C3, but I had invoked C3 at the invoked C3 at the last, but still it got executed and it was created at the second phase. Then we have this C2. So in the initial, the order was C1, C3, C2, but next time the order changed. It came to C3, C1, C2. So this order of execution, it cannot be determined by the human. It depends on the operating system. So this may change. So we have to use some other methods to get a synchronization among these threads. So here, when multiple threads are created, it is creating it will be executed in an interleaved manner. So if we want to get these threads synchronized, then there are other methods to be discussed. We have to implement some other way to bring about synchronization in these threads. So initially C1 was executed. Then the C1 when C1 went to sleep, maybe the C3 thread was created. So C3 got the output, was allowed to display the output. Then when it went to sleep, C2 was created, and it displayed that it got the CPU, and it was allowed to print the data in the screen. Then after that, we see that now when C2 went to sleep, C3 woke up. C3 woke up and it displayed the value 4. But by that time, C1 might have waken up. So C1 was given the CPU. Then since by that time C2 woke up, then C2 was given. So likewise, the order of execution keeps changing. So we cannot determine the order of execution of these threads. So they will always execute in the interleaved manner. So once I value started from 5 to 1, this for loop will be executed, and this thread will keep on executing. So until each thread executes this for loop 5 times, it will be completed. And finally, once all these threads are completed its execution, once this for loop completed the work, we get this output. We get this named out in the output. So once that thread, let's say in our case, C2 completed its work first. So C2 is completing its work, and so what we get, the C2, sorry, not this line, this statement will be executed. So we get C2 exiting. Once C2 completed printing all that values from 5 to 1, that thread will be executed, and once the value became 0, it will exit from the for loop, and it will print that statement outside the for loop, and hence it is C2 exiting. Then once the next case, it was C1 which was completing. So once C1 completed, it will go to C1 completed the output, completed the for loop. When the I value reached 0, C1 will exit, and similarly, so when C3's I value which reached to 0, it also exit. So this is how we can spawn multiple threads inside our program. So here we had created 3 thread objects, and we called the start method on each thread, by which it invoked the run method for it, and we had made use of the runnable interface to create our thread class. So today's video, I had prepared my slide using the textbook Java Complete Reference by Herbert Shield, and I had used the Oracle tutorial by Java on Java, and also the website Java T-Point to prepare the slides of this for today's video. And we had discussed about how to create thread using the runnable interface and the thread class, and how we can create multiple thread inside our program. So that is all for today. Thank you for watching my video. We'll continue in the next session.
Like, share and subscribe. Hit the bell icon for more updates.